subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your physics class, that is your class 31, which we have to cover up here, and that is your 35th class. We had done your unit 1, which is your physical world. Unit 2 is your units and measurement. Unit 3 is motion in a straight line, and this is unit 4, which we have to continue with. That is your unit 4 is your motion in a plane. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So the question we have, we'll start with the question only. The question is, a cricket ball is thrown off a speed of 28 meters second inverse in a directions of 30 degree above the horizontal. You have to calculate the maximum height, then your time taken by the ball to return to the same level, and the distance from that thrower to the point where the ball returns to the same level. These were the three things that you have to find it out. So let's go for the question first. The question is, a cricket ball is thrown at a speed of 28 meters second inverse in a direction 30 degree above the horizontal. Calculate the maximum height, the B is the time taken by the ball, to return to the same level, return to the same level. The C is the distance from the thrower to the point where the ball return to the same level. So for that we'll be going to find it out one by one each. So for the first part, it will be the maximum height is given by HM equals to V naught sine theta naught square upon 2g, which is equals to 28 sine 30 degree square upon 2 into 9.8 meter equals to 14 into 14 upon 2 into 9.8, that is 10 meter. Now for the B1, which we talk about for it, so the time taken to return to the same level is df equals to 2v naught sine theta naught by g equals to 2 into 28 into sine 30 by 9.8 equals to 28 by 9.8 second 2.9 second. Now we talk about the third one. The distance from the thrower to the point where the ball returns to the same level r equals to v naught square sine theta upon g equals to 28 into 28 into sine 60 theta upon 9.8, which is equals to 69 meter. Now discuss about another one, which has been another important topic, and that is about neglecting your air resistance. What does the assumptions really mean? That you have to go for it. So we will find out. Neglecting air resistance. What does the assumption really mean? So for that, it was while treating the topic of projectile motion, we have stated that we assume that the air resistance has no effect on the motion of a projectile. You must understand what the statement really means. Friction forces due to viscosity, air resistance are all that is your dissipative forces. In the presence of any of such forces that opposing the motion, any object will lose some part of its initial energy and consequently momentum too. Thus, a projectile that traverses a parabolic path that would certainly show deviations from its idealized trajectory in the presence of air resistance, it will not hit the ground with the same speed with which it was projected from it. In the absence of the air resistance, the x component of the velocity remains constant, and it is only the y component that undergoes a continuous change. However, in the presence of the air resistance, both of these would get affected. That would mean that the range would be less than the one given by, and the maximum height that attained would also be the less than that predicted. That can you then anyone anticipate the change in the time of flight? In order to avoid the air resistance, we will have to perform the experiment in vacuum or under the low pressure, which is not easy. When we use a phrase like neglect air resistance, we imply that the change in the parameters such that range, height, etc., and that is much smaller than their values without air resistance. The calculation without air resistance is much simpler than that of the air resistance here. Now we talk about for another one, which is being the another important topic, that is uniform circular motion. In terms of uniform circular motion here, When an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. So you just write it down. When an object follows a circular path at a constant speed, the motion of the object is called uniform circular motion. And the word uniform refers to the speed which is uniform constant throughout the motion. Suppose an object is moving with uniform speed v in a circle of radius r, and since the velocity of the object is changing continuously in direction that the object undergoes acceleration, let us find the magnitude and the direction of the acceleration. And for that, let r and r dash be the position vector of v and v dash of the velocity of the object when is at a p here, and then it will be shown typically for the uniform motions here. So for that, the magnitude of a is by the definition that has been given here, which has been was to limit delta t tends to 0, delta v by delta t. Let an angle between the position vector r and r dash be delta theta, since the velocity of v and v dash that are always perpendicular to the position vector, and the angle between them is also a delta theta. Therefore, the triangle CPP that form to the positions vectors and the triangle GHI that form to the velocity vector, and therefore the ratio of the base length and the side length for one of the triangles is equals to the other triangle, which has been delta v by v equals to delta r by r, or delta v equals to v delta r by r. Therefore equals to limit delta t tends to 0, delta v by delta t equals to limit delta t tends to 0, v delta r upon r d delta equals to v upon r, limit t tends to 0, delta r by delta t. Its delta t is small, and delta theta will also be small, and then rp that is being approximately taken to be as, which is delta r upon delta t, which is equals to v, or limit delta t tends to 0, delta r by delta t equals to v. Therefore, the centripetal acceleration is ar equals to v by r, v equals to v square by r. Here for the same, that thus the acceleration of an object that moving with that is the speed v in a circle of radius r that has a magnitude r and is always directed towards the center. This is why this acceleration is called centripetal acceleration, and a term that is proposed by Newton, where that is a thorough analysis of centripetal acceleration was Christian's Huygens in 1629 and 1695, but it is known as Newton's, and also some years that is that centripetal comes from the Greek term, which means your entire seeking, center seeking, and for that acceleration it will be going to the time rate of the change of angular that is displacement, which has been known as omega. So for omega it will be that will be representing. And now we will be having a question here, which is an insect trapped in a circular grooves that of radius 20 centimeter moves along the groove steadily and completes 7 revolutions in 100 seconds. What is the angular speed and the linear speed of the motion, and is the acceleration vector of a constant vector? What is its magnitude? So we're going to find out those terms as well. So here we go for it. So let's find it out. An insect trapped in a circular groove of radius 12 centimeter moves along the groove along the groove steadily and completes 7 revolutions in 100 seconds. What is the angular speed and the linear speed of the motion? The acceleration vector, a constant vector, is the acceleration vector or linear speed of the motion. Is acceleration vector a constant vector? That is, we have, and what is the magnitude? Now we go for the solution here, and on the same way, this is an example of a uniform circular motion, so where r equals to 12 centimeters, so the angular speed omega is to be given as omega equals to 2 by t, which is equals to 2 pi into 7 upon 100 equals to 0.44 radians by second. The linear speed we have equals to, that is v equals to omega r, and that is 0.44 second inverse into 12 centimeter, which will give you 5.3 centimeters inverse square. So the direction of velocity v is along with the tangent of the circle at the every point. The acceleration is directed towards the center of the circle, and since the direction changes continuously, the acceleration is not constant vector, and however the magnitude of the acceleration is constant. So a equals to omega square r, which is equals to 0.44 second inverse square into r is 12, so it will give you 2.3 centimeter second inverse. Now on the same way, we're gonna end up with this unit, which is motion in a plane. So for that we have many more things that to be discussed about the scalar quantity and the vector quantity as well, and we had even though done that. And other than that, we have your physical proper quantity symbols and dimensions with their unit, and there of course the remarks as well. So for that we gonna start with the another important class. Of course in the next coming class we will be discussing those as well. So but other than that, where scalar quantities are the quantities with magnitude only, and the examples are the distance, speed, mass and temperatures as well. And where the vector quantities are the quantities with magnitude and the direction both. An example of displacement, velocity and acceleration, they will be the special rules of vector algebra. Where we have discussed about the motion in a plane that can be treated as a superpositions of separate, and where when an object that follows a circular motion, which we had done, and then of course the motion of an object called uniform circular motion, and the magnitude of the acceleration direction is always towards the center of the circle here. So for the same we have that the angular speed and the rate of the change of angular motion, it is related to the velocity, the acceleration, and that is the t of the time period of the revolution of the object in circular motion, and that is v. It's frequently we have. For the same we go for the points to remember as well, that you have to remember about it. So which has been the another important one. So we go for the same here, we discuss about it, and that is when an object that follows a circular path at constant speed, and that the motion of an object being called the uniform circular motion, where the magnitude of the acceleration is your delta AV, that is of v by r, and that the directions of a is always towards the center of the circle. The angular motion of omega, that is the rate of the change of angular distances, it is related to the velocity and in the time given period revolutions of an object in a circular motion. And v is the frequency here. For the same we talk about it, and that is your against that the motion. V is its frequency, and we have your 2 pi v, where v equals to 2 pi vr, and av of equals to 4 pi square v square by r. Now for the points that to be remembered here, which has been the path length that is traversed by an object between the 2 points is in general and not at the same as the magnitude of the displacement, where the displacement depends only at the end of the point, and that the path length that as the name implies, and that depends on the actual path, where the two quantities are equal only if the object does not changes its direction during the course of the motion, and in all the other cases the path length is greater than the magnitude of the displacement here. So for the same it will be in a review of the point one, that will discuss that average of an object that is greater than and equal to the magnitude of the average velocity over its given time interval. The two are the equal only if that the path of the equal and magnitude of the displacement, where the vector equation that do not involve say any choice of course, you can also resolve them along with any two independent axes. The kinematic equations for the uniform acceleration do not apply to the same case of the uniform circular motion, and since in this case that the magnitude of acceleration is a constant but its direction is changing, where an object subjects to the velocity v1 and v2 that have a resultant velocity, and the resultant acceleration of an object that is in the circular motion is towards the center only if the speed is a constant, and that the shape of the trajectory of the motion of an object that is determined by the acceleration along, but that depends upon the initial condition of the motion and initial position and initial velocity. For example, the trajectory of an object that is moving under the same acceleration due to the gravity, that can be the straight line and the parabola, that is depending upon the initial condition. Same way we go for the questions here where we deal with it, and that is the question we have. State for each of the following physical quantity if the scalar or vector volume, mass, speed, acceleration, density, number of moles, velocity, angular frequency, displacement, angular velocity. Other question is, pick out the two scalar quantities in the following list, which is force, angular momentum, work, current, linear momentum, electric field, average velocity, magnetic momentum, relative velocity. Pick out only the vectors or quantity of the following list, that is temperature, pressure, impulse, time, power, total path length, energy, gravitation, potential, and coefficient of friction and charge. State which of the reason whether the following algebraic operation with a scalar and the physical quantities are meaningful. Adding any two scalar, adding a scalar to a vector of the same dimensions, multiplying any vector by a scalar, multiplying any two scalar, adding any two vector, and adding a component of a vector to a same vector here. Now we'll discuss for the another one, and that is we have, which is read each statement that is below to the carefully state with reasons if it's true or false, and establish the following vector inequalities, geometrics or otherwise. A plus mod of a plus b, and on the same way, what does the equally sign above apply, and the magnitude of a that can never be greater than sum of the magnitudes of b, c, d. Here three girls are skating on a circular ice ground of the radius 200 meters start from point B and the edge of the ground, and then of course to the different path that to be shown, and what is the magnitude of the displacement vector for each, which girl is equals to the actual path of the path skate. Now another one which we have here is the another question. A cyclist starts from the center O at a circular park of the radius 1 kilometer, reaches to the edge P and the park, and then cycles along the circumference of the returns and to the center along with OQ, and that is at the round trip that takes 10 minutes. What is the net displacement, average velocity, and average speed of the cyclist? Another question we have, on an open ground, a motorist follows a track of the turns to his left and the angle of 60 degree after every 500 meters starting from a given turn. Specify the displacement of the motorist at the third, sixth, eighth turn. Compare the magnitude of the displacement with the total path length that is covered by the motorist in each case. A passenger arrives in the new town, wishes to go from the station to the hotel located 10 km away from the straight road from the station, and a dishonest cabman takes him along a circuitous path of 23 kilometers long and reaches to the hotel in 28 minutes. What is the average speed of the taxi, the magnitude of the average velocity, and are the two equals? And the question is, rain is falling vertically with a speed of 30 meters second inverse. A woman rides a bicycle with a speed of 10 meters second inverse in the north to the south direction. What is the direction of which she should hold her umbrella? And the question, a man can swim with a speed of 4 km per hour in a still water, and how long does he take to cross a river 1 km wide if the river flows steadily at 3 km per hour and makes his strokes normal to the river current, and how far down the river does he go when he reaches to the other bank here? Now here we're gonna end up with this only, and we'll discuss the rest of the questions in the next coming class, which is about another question, and that is from 32th class. So other than this, here we're gonna end up with, and before ending it up, it's a huge request to all the viewers to please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Other than this, we had done your reasoning, which is your verbal reasoning and non-verbal reasoning. We had started done your quantitative aptitude, where we had started with arithmetical ability, where we had done your 17 topics. We had started done your chemistry part 1 and chemistry part 2 we are dealing here, where in that as well we had done your 3 units. Coming towards physics part 1, which we had done your unit 1, which is your physical world, unit 2 units and measurement, unit 3 is your motions in a straight line. Unit 4, which is your motion in a plane, that will surely complete in the next coming class. After that, we'll start discussing about the unit 5, which is laws of motion. Unit 6, work, energy and power. Unit 7 is system, particles of rotational motion. And unit 8 is your gravitational motion. So thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on a comment box. Thank you.